Hello everyone, you are watching my YouTube channel Chemistry by SaadAnwar. If you want to enjoy my one-on-one tutoring session, feel free to contact me at given WhatsApp number. Next question is 23. This is visible to you. What is the mass? What is this question? What is the mass of sodium hydroxide in grams present in 2.3 liter? This is volume. 5.4 molal sodium hydroxide. This is molality. Molality is kind of concentration. Like to express concentration, we use different units. One is molarity. This one is molality. Molality is when you divide moles by mass of solvent. This is called when you divide moles of solute. When we divide moles of solute, solute can be salt, solute can be sugar, solute can be glucose. When we divide moles of solute by mass, mass of solvent, we get something, and that something is molality. And Stephanie, if I divide moles of solute by mass of solvent, no, volume of solution, volume of solution. Then I get something, we call it molarity, which I guess you are familiar with this term molarity. So molarity, both are cousins. Density of solution is given. This is the answer. Let's go to whiteboard. So what is the mass of sodium hydroxide in gram present in 2.30 liter? It means volume given to us is 2.30 liter of 5.4 molal. So molality, Stephanie, molality given in the question is 5.4 molal. The density given in the question is 1.15 gram per ml. What I have to find, what is the mass of sodium hydroxide in gram? So we have to find mass of sodium hydroxide. When I was struggling to solve that question, I went through many questions similar to this one, but not exactly, but quite similar to this one. This question is quite challenging. I found this question is quite challenging. And okay, we have to find mass of sodium hydroxide, and sodium hydroxide air is my solute. So the formula which we have to use is molality is equals to moles of solute. Solute is my sodium hydroxide here, divided by mass of solvent. So everything is simple in that question. The challenging is how to get mass of solvent. This is density of solution. This is density of solution. First, what mistake I did from density of solution, I got volume of solution. And then I got mass of solution. From density, I got mass, and I put mass here. That was a mistake because they are asking mass of solvent, not mass of solution. So let's find by using this density, let's find mass. First, we try a little bit. Any idea when density is given, when volume is given, how to find mass? Any idea, Stephanie? Try to do that. Any idea?
think it was um density equals volume over mass.
Very good. But density is equals to mass over volume. Very good. Very good.
Oh, oh,
Excellent. Density is equal to mass over volume. Mass is mass is I have to find mass. Volume is given. Density is given. Game seems very simple. So I take volume factor here. So density would be equal to density times volume. That would give me a mass. This is density of solution, so I would get mass of solution. Density is 1.15 gram per ml. Volume is 2.30 liter. Problem arise here because in density the volume is in ml while that volume is in liter. So I have to convert this ml into liter as well. How? How I know, Stephanie? I know this. 1 liter contain, oh, 1 second. So I have density in gram per ml. Let me convert in liter, kilogram per liter, because mass of solvent also should be in kilogram. In molality, it's criteria that mass of solvent should be in kilogram. If it is not, convert this into kilogram. So, so I now 1 liter contain 1,000 space. I now one density is 1.15 gram over ml, and I have to cancel ml, and I have to put liter here. I now 1 liter contain 1,000 ml. Okay, so this ml would be cancelled by this ml. This ml would be cancelled by this ml. And when I multiply with 1,000, my density would be gram per liter. But I do not want gram. I want kilogram. So let's do that conversion. I know, Stephanie, I have to cancel out gram. I know, and I have to cancel out gram and I have to put kilogram. I know 1 kilogram contain 1,000 gram. If I write like that, then this is possible that I can cancel this gram with this kilogram. This is unit conversion approach. First, I cancelled ml. I have to cancel out ml so that I can get liter. Then I have to cancel this gram and so that I can get in kilogram. If I write like that, then this is possible for me to cancel gram with that gram. In unit conversion, usually students commit mistake because they forget to multiply, to divide. So that is challenging. So put like that, then it would be very easy. No needs to think like that. Should I multiply? Should I divide? No need to think like that. Just write down like that way. Then it's easy to figure out should we multiply, should we divide. When I write like that, the good thing is I do not need to use calculator because I can see this 1,000 would be cancelled by this 1,000 and my answer remains same. But now the unit is kilogram per liter. Now, Stephanie, here I put that units kilogram per liter. You can ask me, we did conversion, still the value of density remains same. Yes, you see how it remains same. Still the value of density remains same because during unit conversion, what we put, they cancelled with each other. Now this later would be cancelled with this later when I multiply 1.5 with 2.30, I would get what I would get what I would get, that would be mass of solution. So what you would get, Stephanie?
It would be 2.645.
Very good. 2.645 kilogram. This is mass of solution. So when I was doing that question, what mistake first I did? I put this mass here. And my answer is very close to the exact answer, but not exact answer. But we cannot put like that because in molality formula, I cannot put this mass because definitely this is mass of solution. While in molality, I have to find mass of solvent. I have to put mass of solvent. So I am sharing with you my experience because when student would get when I myself when I got mass of solution, I was very happy that I got mass. I immediately put mass here. I cannot put mass of solution because in exact molality formula, they need mass of solvent, not solution. And to find mass of solvent, that is challenging. Comes to the next thing. Mass of solution, because solution is a solution means mass. Solution means two things. One is solute, other is solvent. So mass of solution means we are talking about mass of solute and we are talking about mass of solvent. So Stephanie, I have mass of solution. I struggled here to find mass of solution. So if somehow I would get mass of solute, I get mass of solvent?
Yes.
Yes, then I can get mass of solvent if I rearrange the equation because I have mass of solution. If someone tell me about mass of solute, then I can get mass of solvent. But problem is in that question, nobody has given us mass of solute. Like we have no value of mass of solute. We have no value of mass of solvent. So we cannot put mass of solute here. We cannot get mass of solvent. If someone inform us about mass of solute, then we put mass of solute here, we put mass of solution here. It's quite simple to get mass of solvent then. But we do not know about mass of solute. So we cannot get mass of solvent by using mass of solution. So what we do, if you want to write few things, you can write, then I would turn the page.
Okay, I got it.
Very good. So mass of solution is equals to mass of solute plus mass of solvent. I need mass of solvent. What I do, what I do, I would bring mass of solute to the other side. So formula would be mass of solution. When I bring mass of solute to the other side, it would be minus mass of solute minus mass of solute. This is mass of solvent. Now I can put mass of solvent, although problem is still there. I do not have mass of solute, but I have mass of solution, and that is you got yourself 2.645. Uh, anyway, I do not know mass of solute. If I know, that would be more good. Then I can get mass of solvent, but I do not know about mass of solute. So what I do here, I would put mass of solute as such. and this is mass of solvent. Okay, so I can use this one as mass of solvent. Although this seems quite strange because I do not have mass of solute, so this is not exact something, but I would use this as a mass of solvent. Where I would use this in that formula, that molality is equals to moles of solute over moles of solute over not volumes. In molality, we talk about mass of solvent in kilogram. So molality value given in the question is 5.4. Mass of moles of solute, I do not know. I would put this as such. I have to find this. Mass of solvent, which is in green box. And this is 2.645 minus mass of solute. I would bring this factor here so that I can get moles. So 5.4 times 2.645 minus mass of solute is equals to moles of solute. Moles of solute. So Stephanie, multiply 5.4 with 2.645. When I multiply these two values, I would get 14.283 kilogram. So also multiply 5.4 with that factors because this is in bracket. So when I multiply 5.4 with mass of solute, so it would be 5.4 mass of solute. Whatever the mass of solute is, but now it is with 5.4 because I had to multiply 5.4 with this. I had to multiply 5.4 with this moles of solute. Here I can put mass of solute because you know moles is equals to mass over molar mass. So sodium hydroxide, its molar mass is 40 gram per mole. So when I calculated this into kilogram, I divide with 1000, it would be 0.04 kilogram. So this is 14.283 kilogram. This is 5.4 mass of solute. Here mass of solute, which I have to find as well in the question, I do not know. Molar mass is 0.04. So what we do now, Stephanie, just bring this factor to that side. When 0.04 goes to that side, it would also multiply with it. Write down this. When finish writing, also multiply 0.04. Like bring 0.04 to that side. Put here as you did with this. When I did this, it would be 0.04 times 14.283 minus 0.04 also multiplied with this factor. 0.04 times 5.4 mass of solute is equals to mass of solute. So just multiply these two values, 0.04, 0.04 times 14.283. This would be equals to 0.57132. When I multiply these two values, 5.4. This would be equals to 0.216. And this is mass of solute. And here I have to put as mass of solute. What I do now, keeping 0.57132 here, I would bring this factor to other side. When it goes to the other side, it would be plus, like this is mass of solute, plus when I bring this factor to the other side of equality, it would be plus 0.216 mass of solute. Definitely, this is 0.216 mass of solute. This is one mass of solute. Like if I ask you add 1 plus 1, you would say 2. If I ask you add 2 plus 3, you would say 5. If I ask you add 1 plus 0.216, what you would get when you add 1.1 plus 0.216, like this is when there is nothing, it means there is 1. So add 1 kilogram mass of solute plus 0.216 mass of solute. That would be 1.216 kilogram mass of solute. There is 0.57132. One kilogram mass of solute plus 0.216 kilogram mass of solute. Total 1.216 kilogram mass of solute. Here I have 0.57132 kilogram. I want mass of solute. 1.216 kilogram is extra. I would take this to other side. Here this is multiplying. When it goes to the other side, it would go in division. So 0.57132 divided by 1.216 give you mass of solute, which is a sodium hydroxide. So just solve it. 0.4698 kilogram. Now just convert into gram.
Mm, it would be
Multiply with 1000.
469.8.
469.8.